The notes, have the notes out. Somebody help me out and remind me my screen's messing up, so as I record stuff, it's not showing up like normal.
You're right there, though. That's true. It's in freaking Mr. Ebersole. How quickly do you think this will charge your phone?
My phone?
I don't know if I do.
Jeez, dude. That thing is massive.
Oh, sorry.
I know what math is. Oh, no. I was making sure you see it.
Paper etiquette, not turning it into.
Hey, did you turn 15 today?
Yeah.
This is
That's a young
August 14th.
3 days after one.
That's sad. But you're such a young. Why is she so old? Me? Yeah, why is she so old? Yeah, Morgan's not. Kelly's normal.
She'd be how old is Morgan? She'd be like the youngest sophomore ever. How old is Morgan? She's 15. She's been 15 or almost 15?
I turned 16 the first week of school.
She's 15.
I would either be, I'm a really young sophomore, but I'll be a really old freshman.
I was born in August.
I should be a freshman.
Dude, senior year, come on, one second. I think it might be Tate.
How old are you?
His birthday's in June.
Or you think
Listen to the time I graduate.
Yeah, but she didn't.
By the time I graduate, he's only 21.
Why is he not a sophomore?
Yeah. Because he only turned 16.
Straight out of high school. Straight out of high school.
Yeah, but if you're like born later, you have to wait a whole extra year.
Will they get your permanent?
No. I wish I was a freshman.
I used to when I graduated school. I'm like, dude.
Alright, on this, polygons.
I would give me more maturity. Thank you.
On this, polygons, we're going to go over some of this. This will be sort of a messed up chapter because I'm doing things out of order a little bit. So you just have to follow along. Michael, put that away. Threw it away. No food. Tired of picking up trash off the floor and stuff, so
It's away.
get back to being a jerk. With polygons. Somebody check real quick, because I'm worried now. We may have to do something else here in a second. Look at the assignment. What page is that assignment on? Somebody check their book. Might not be in this book.
Uh-oh, we might need a new book.
Yeah,
it only goes to 400. Alright, so here in a few minutes we'll get that. So dealing with polygons, find and use the interior angles of a polygon, find and use the exterior angles of a polygon. There's going to be 4 main formulas. 4 main formulas. I was looking at my book. Looking at it in the hallway here in a second. Kellen. I'm not having this discussion with you today, man. Yes, sir. Just go to the hallway if we're going to have this discussion. I'm not going to mess with you. 4 main formulas that we're going to use. All right? Not very difficult formulas. We're finding the angles of all the different polygons. So when you write down these formulas, make sure you write them down correctly and so that you can read them. We covered convex and concave polygons.
Can you do like a little circle thing? What is that? Right there. It's a circle. Draw. No. Can you draw? Yeah. Please. No. Not right now. Later. No.
Convex and concave polygons, we covered these like chapter 2 or something, way back at the start of the year. Convex are the ones that we're going to be dealing with. We'll deal with some concave also, but convex are the main ones. They're the ones that fit all the rules that we're going to deal with. Concave. A concave polygon, it doesn't have to look like this one, but it's always going to have at least one angle, ignore that, at least one angle that's more than 180 degrees on the inside. So at least one interior angle that's more than 180 degrees. Notice on these, all of these angles, less than 180. They don't always have to be the same, but they all got to be less than 180 to be a convex polygon.
Really make sure it's in there.
We're really going to make sure that it's in the trash here in a minute. Because I'm not messing with it.
What do you call angles that are more than 180 degrees?
We're not going to go into that. They do have a special name, but we're not going to talk about it because it's just something else to.
And what's the first blank?
Yeah, first one.
Where's it at?
Connects
it's
two
just like right-
non-consecutive vertices of a polygon.
Oh, I just got them out of order. My slides must have got messed up. It's probably on the next slide.
Oh, okay.
We talked about diagonals earlier this year, drawing diagonals in. Diagonal connects two non-consecutive vertices of a polygon. Should probably switch those around, I guess, but doesn't really matter. You guys can figure it out, right? So all a diagonal is, first of all, if I'm looking at this triangle, no diagonals. It's not possible to draw a diagonal in a triangle, all right? Because there are no non-consecutive vertices. Vertices confuse you. That means corners. No non-consecutive corners for a triangle. For a quadrilateral, a four-sided figure, that's a diagonal. Connects those two. Does it have any other diagonals? Yeah, going the other way. Now, when we talked about, so you could also draw one this way. We talked about stable, last chapter about stable figures, and we said you just draw in that one diagonal. Well, it's also got the other diagonal here, but you don't have to draw it in for the shape to be stable, so on and so on. This pentagon, five-sided figure. That would be a diagonal. I'm not sure if I have more of them on here. That would be a diagonal. There's the other one on that one that I just drew in there. That's a diagonal. I'm not sure why I got them out of order. That's a diagonal. That's a diagonal. So a pentagon has all of those diagonals. If we want the figure to be stable, we don't need all of them, but all of those are possible diagonals. Notice when you draw all the diagonals in a pentagon, what do you get here in the middle? A smaller pentagon. And it's upside down. It's like flipped over it. Polygon, interior angle theorems. Might want to put an asterisk beside this. This is for interior angles. Interior angles means what? Inside. We're going to deal with interior angles and exterior angles. Interior angles inside the polygon, exterior angles outside the polygon. This is the key to all of this. Let's erase all that. Doesn't like this slide. Went slower, didn't do no good, did it?
No, I just added more.
formula, key to all of this. 180 times n minus 2. A lot of times, I turned it around. That's the sum of the interior angles. If you see it in the book or somewhere else, instead of saying it that way, it'll say 180. See if I can't write it up here somewhere. It'll say n minus 2 times 180. It'll have it turned around. I put the 180 out front because that's what you guys are used to seeing. All right? With something out in front of the parentheses. If that's out in front of the parentheses, what's it tell us to do to everything inside? Distribute it out if we need to. Now, n stands for the number of sides. Very important that you know n stands for the number of sides. So if we have the shape and we can count the sides, then we'll know what n is, and we don't need to distribute. We'll just do the math. Okay? So if we count the number of sides and it's 10, the shape's got 10 sides, then we put 10 in here, and what do you do first if you put 10 in place of n right there?
Subtract 2.
So 10 minus 2 is what?
8.
And then you take that 8 times the 180. All right? And that tells you the sum of all the angles inside. How many, if it's a 10-sided figure, how many angles should it have? 10. All right? If it's a 5-sided figure, how many interior angles is it going to have? 5. We're finding the sum of all those angles. The sum of them, not each one separately, but the sum of all of them. Like right now, we know that the sum of all the angles of a triangle is always how much? 180. All right? Then we're going to find a 4-sided figure, a 5-sided figure, 6-sided figure, 7-sided figure. So no matter how Cameron draws a 5-sided figure, maybe he draws it and it looks something like that. All right? If it's got 5 sides, these 5 angles always add up to a certain amount. And that's what we're going to figure out. That's what this formula allows us to figure out. So no matter what 5-sided figure you see in the world, the 5 interior angles are always going to add up to a certain amount. Same thing for a 6-sided figure, a 7-sided figure, 8-sided figure, so on, so on, so on. So that's for the sum of the interior angles. Sum of the exterior angles of a polygon. Sum of the exterior angles. If it's a 10-sided figure, it's got 10 sides, and it's got 10 interior angles. Guess how many exterior angles it has? 10. So the number of interior angles, number of exterior angles, number of sides, always the same for every shape in the world. The sum of the exterior angles, this is like the easiest one. The sum of the exterior angles is always going to be 360. There's nothing to figure out. If I say you have a 10-sided figure, what's all 10 exterior angles add up to equal? 360. If I say it's a 12-sided figure, what's all 12 exterior angles add up to equal? 360. If it's a 4-sided figure, what's all 4 exterior angles add up to equal? 360. The exterior angles of any shape in this world, any convex shape in this world, always adds up to 360. How many exterior angles does this shape have? 7? Does everybody agree with that? What do they all add up to? 360. All right? We don't know what each one of them is right now, but we do know that they all 7 of them have to add up to 360. So if I told you this one was 100, this one was 20, this one was 30, this one was 40, I'm just making up numbers here. This one was 50, this one was 60. Could you find that last one?
Yeah.
You'd add all these up and subtract that number from what? 360, and that would tell you how much is left over for that final one. 16. What is it? 60. So interior angles, sum of all the interior angles, n minus 2 times 180. That's the sum of all the interior angles. Sum of all the exterior angles is always 360 degrees. Those are two of the formulas. This word, regular polygons, was on your crossword puzzle. A lot of people still don't know it. Got to know if a polygon's regular, all the sides are equal, and all the angles are equal.
Someone told me to tell you to drink water, and you told them to drink water.
Mason, move that noggin. I can't see. Thank you.
If a polygon's equilateral, that means all the sides are equal. If it's equiangular, that means all the angles are equal. If it's both equilateral and equiangular, then we call it a regular polygon. Triangles, if I draw an equilateral triangle, ignore that. If I draw an equilateral triangle, we know all the sides are equal, but what else do we know?
Oh, the angles.
All the angles are also equal. That only works for a triangle. All right? A triangle, if it's equilateral, it has to be equiangular. And if it's equiangular, it has to be equilateral. 4-sided figures, 5-sided figures, 6-sided figures, doesn't work that way. Perfect example. Home plate on a softball or baseball field. Ignore all that. Home plate on a softball or baseball field, all of these edges are 10 inches. You can go out and measure them if you want. I'm telling you that that's what they are because I know.
Are you
So all of them are 10 inches. Are all the angles the same in that home plate?
No.
No. As a matter of fact,
couple right angles?
this angle is a right angle. What's this angle?
Right angle.
A right angle. Guess what this angle is? It's a right angle also. It has 3 right angles. And after today, you're going to be able to figure out what these other 2 angles are
Because they're congruent, right?
because they end up being congruent, and we'll know that all 5 of these angles have to add up to a certain amount. And as a matter of fact, we should already know what they all add up to. How many sides does that shape have?
5.
So it's 5 minus 2, and we're going to take that answer times 180. What is 5 minus 2?
30.
Have your calculators out because we're going to need them here in a second.
540.
What is it?
540.
540. If all 5 of these angles add up to 540, what can we do to find this angle right there?
270 minus 540.
So take 540 minus 270.
Divide that by 2.
What's that leave you with?
270.
270. And then we're going to do what with that number? Divide it by 2.
135.
So each of those angles, you can go out and measure them on home plate. Each of those angles is 135 degrees on every home plate in the world. Get yourself in trouble. Hurry. So, triangle has to be equilateral and equiangular at the same time. Other polygons don't have to be. And quadrilateral. Give me a quadrilateral that's equilateral
A square.
but not equiangular.
Oh, rhombus.
A rhombus.
Oh, okay.
All right? It's equilateral. All 4 sides are the same, but all 4 angles aren't the same. All Alright? Give me a quadrilateral that's equiangular, but not equilateral. A rectangle. Now give me a quadrilateral that's equilateral and equiangular. A square. Alright? If regular, notice, these say each interior angle, each exterior angle. These are the formulas for those, the other two formulas. So we know the formula to find the sum of the interior angles, the formula to find the sum of the exterior angles, which is always 360, so there's really no formula. This is to find each one. This only works if it's a regular polygon or it's equiangular, where all the angles are the same. That's the only time it works. I know it didn't mess up.
I know, but at the same time, we're making progress.
Beside this formula, and you do whatever you want to do as we do these problems, I never use that formula. And I'm going to explain why here in a minute. Which of these two formulas looks easier?
The bottom one.
The bottom one. And we'll write this down below here. If I draw any shape and it's regular, this is an interior angle here. Ignore that. What do you know about that interior angle and that exterior angle? They're supplementary. They add up to 180. So down here below, and I might not be able to write this because of the way this is messing up. Each interior angle plus each exterior angle add up to how much? 180 degrees. So when I say I never use this formula, the reason I never use it, I think it's easier to use this formula because it only takes 360 divided by the number of sides. Find each exterior angle, then subtract that from 180. So if that's not what Luke wants to do, if he wants to use that top formula, that's fine. It's not a hard formula or anything. Alright? Just, if you do this, then subtract from 180, you'll get each interior angle. So let's do one that's easy. If we have a square, we know square, all the sides are the same. What's each interior angle? 90 degrees. So let's see if this formula actually works. On this formula, I said I never use it. I'm going to use it right now. Have your calculator out. What do we put in place of n? 4. It's got 4 sides. So 4 goes there, 4 goes there. What is 4 minus 2? 2. Then take your calculator. What's 2 times 180? 360. So you end up with 360 on top. You got to make sure you do all that top first. Then you divide that 360 by 4. What do you end up with? So how much is each interior angle for a 4-sided figure if it's regular? 90 degrees. Alright? what should each exterior angle out here be? If I drew an exterior angle, what would it be? 90 degrees. Let's take this one. What's 360 divided by 4? 90. So each exterior angle is also 90. Let's do a triangle. Since you know that a triangle, if a triangle is equal angular, each angle is how much?
60.
So 60 degrees there, 60 degrees there, 60 degrees there. If I draw an exterior angle, we did this last chapter. If this is 60, what's this angle out here? 120. How many sides does a triangle have? 3. What's 360 divided by 3? 360 divided by 3. Use your calculator. Is that what we said?
Yeah.
And you can do that with every shape. 3-sided, 4-sided, 5-sided, 6-sided, 7-sided, 8-sided. As a matter of fact, you're going to here in a minute. So the formulas that we have, and I think they're all on one slide here in a second. Sum of the interior angles, all the interior angles added up for any polygon, n minus 2 times 1/8. Sum of the exterior angles, always 360. Each interior angle, and this only works if the polygons are regular, each interior angle is n minus 2 times 180 divided by n. Each exterior angle is 360 divided by n. Those 4 formulas, that's the main stuff for everything that we're doing today. Yep, I was right. It is on this.
Score prediction for Wednesday.
I'm predicting the score.
I think Trail's gonna catch it.
Do what?
I said, do you think Trail's gonna catch it up now?
Yeah. I not think that.
Best team in the nation right here. 100%. And I remember playing that game. We should get Chick-fil-A to bring it.
Can't wait to go to Butler to play Miami East at Lily Beach.
Tell it.
So, on those formulas again, make sure that you realize these top 2 formulas, all polygons. If those 2 work for any polygon, all convex polygons. The last 2 only work if the polygons are regular or equal angular. Regular or equal angular. On this chart, get your calculators out because you're going to fill it in. You want to do the easy parts first? Alright, so first thing, names. Let's do the names column first. A 3-sided, what's that? Triangle, write that in there. Four-sided, quadrilateral. Quadrilateral. If you spell it wrong, I'm not really all that concerned about it. Quadrilateral. Quad means 4.
You're so smart.
5-sided.
Pentagon.
Pentagon. Pentagon. Might want to be filling this in instead of drawing pictures.
I like drawing pictures. I was enjoying myself. What we're doing?
6-sided.
Hexagon.
Hexagon. Hexagon. 7-sided.
Septagon.
7-sided, and we wrote these down earlier this year also.
Heptagon?
It could be either one. It's either a heptagon or a septagon.
Which one do you want us to write down?
Second one.
And you'll see both of them in your life probably, so you need to know that either one means a 7-sided. Heptagon,
Nonagon. You should add.
septagon.
You should add more like pentagons and stuff into your notes.
That's 9. That's what I'm saying.
8-sided,
Octagon?
octagon,
Octagons look good also.
octagon,
Isn't that like a UFC break?
Yes.
Fight in the
I'm gonna get that wrong.
9-sided,
Like nonagon?
non-agon. Non, N-O-N-A-G-O-N.
I can't remember. Why don't we do 11?
Because you can't make it 11 smash.
10-sided,
Decagon.
decagon, D-E-C-A-G-O-N.
Is this the next? Oh, Decagon is.
Yeah, it's great.
Now, an 11-sided, how come I didn't put 11 on there?
Probably every.
You just don't, it doesn't get used,
They only just made it 11-sided too.
alright? 12-sided, does anybody remember what?
Dodecagon.
Dodecagon, D-O-D-E-C-A-G-O-N. Dodecagon, now it's a dodecagon because of what? Do means
2.
and deca means
10.
10. 2 and 10 give you 12. N, the last one down here.
Polygon?
We call it just n-gon, where n stands for what?
Any number.
Number of sides. Number of sides. So, instead of trying to remember names for all the different polygons that are in the world or could be in the world, if we get past 12, we normally just say it's an n-gon. So if it's got 25 sides, and I ask you to name it, then you write it is a 25 dash gon.
Are we gonna have to throw something like this out on like a test or something?
I don't know, we might do that because I'm getting annoyed by some of these people that aren't bothering to write it down. Since they're not bothering to write it down, and I let you use your notes most of the time on the test, and they don't write it down, then I'll,
You can, this is 3 points.
all right, not for some of them, because they aren't writing it down.
Sure.
I'm trying to draw 11-sided shape.
No, I left it in my bag.
I don't care what you're doing, you're not doing what you should be doing.
How do you draw?
I like that.
That's what I'm trying to figure out.
Next one, the easiest one, which column's the easiest?
Triangle.
Which column?
The exterior.
Some of the exterior, because what?
It's always 360.
So what can you do in that column?
Just write 360.
Get it?
And
For all of them?
Yeah.
So the sum of the exterior angles, what do you know about the sum of the exterior angles? For any polygon?
It adds up
It's
to
always 360. Those always, the exterior angles always add up to 360 degrees.
How come, like, how does that work exactly?
When you're drawing, when you have whatever polygon it is, we got this pentagon, and we draw the exterior angles for all of them. What you're actually sort of going to, it's like you're making a circle with those exterior angles. And how many degrees is there in a circle? 360.
We could use that and make a perfect circle.
I like saying I'll get to be a doctor.
you just go with it. It's like light.
Some of the interior angles, let's go back a column. Some of the interior angles, this is where you're going to have to use your calculator. And I'm not going to tell you all these. Hopefully you guys will tell us. So if you're sitting here doing nothing, then oh well. We just won't fill them in, and then only the Johnnies of the world will have them filled in, and maybe I will throw this on the next test. First one, for a triangle, What's the sum of the interior angles of a triangle? 180. So you can write that one in. That's pretty easy. The formula for this column.
Sorry, I want to do this in.
Hinge. The formula for this column is n minus 2 times 180. So when you're grabbing your calculator, you're going to take the number of sides minus 2, then take that answer times 180. That's going to tell you what goes in this column. All right? For a four-sided figure, what's 4, and I'll help you out with the first one, then you can start filling them in. What's 4 minus 2? 2 times 180? 360. So what goes in right here? 360. The sum of the interior angles of any four-sided figure is always 360 degrees. Next one. If we stick 5 in there, what's 5 minus 2? 3 times 180? Now you're on your own. Help each other if you want. Tell each other what the next one is and the next one. Otherwise, just don't fill it in.
540, 720, 900, 180, 1,008.
They go up by 180 each time. Just after they do one.
What'd you do in?
Huh?
You did the in.
I just put this.
He's right. For the formula down at the very bottom for n, you just write in what?
N minus 2 times 180.
N minus 2 times 180. Just write in that formula.
I looked through that.
Yeah.
I don't want to see that. Just add it. Just add 180 stuff.
Oh! Because each one of them has to equal 180. Each one has to equal
Just add 180 to it.
Right. I get why the formula works now. Because they all make straight lines.
Do we need this number?
All lines are straight.
You know what I mean?
It was up there.
They don't make angles, they make straight angles. There we go. That one's good.
That didn't make any more sense than a straight line.
They make linear pairs.
Is this a worksheet?
Has everybody got all those?
Yeah.
Close?
This math.
We already got this column, right? What were all them?
360.
Oh, wait, here.
Which one of these two is going to be easier to find?
That's
The exterior angles. The exterior angles, you're just going to take the sum of the exterior angles and divide it by what? Number of sides. So you're going to take this column, which is always how much? 360, and divide it by the number of sides. So remember that these two only work if the shape is regular. All right? For each exterior angle on a three-sided figure, what's it come out to be? 120. About for a four-sided figure?
90.
About for a five-sided figure?
72.
72. Everybody agree with that? Yes, no, maybe?
Yes.
Each time you're just taking 360 and dividing it by what?
The number of sides.
Number of sides. Finish it out.
Are we supposed to get decimals?
You can.
Do we just round it?
Yeah, you might just want to leave it blank, and we'll talk about it here in a minute. So if it doesn't come out all nice and even, maybe leave it blank, and I'll tell you what to fill it in with. hopefully you'll notice which ones do you get decimals on.
The odd numbers.
The ones that you don't
Use.
use.
I did it.
7 and
I
7.
got it.
Seven's the only one.
Yeah. I
I
got
got
this
my
one.
11 sided sheet.
How often do we use a seven-sided shape?
45.
Not very,
Not very often.
Is it?
You did 360 divided by 8. And
Mr.
No. I can set you out in the hallway here in a second if you keep talking to me about stuff that we're not discussing in this classroom.
so what would the last one be?
What was what?
The last one would be,
The one for the formula?
yeah, would it be like,
360.
360 over n. So for the very last one, it's just 360 over n. It's just the formula. Now, as you're going down through there, do we use three-sided figures? Is that something we use in the real world? Yeah. Do we use four-sided figures? Yeah. Five-sided figures? Six-sided figures? Seven-sided figures?
Not as much, but probably.
Not really. And that's the one that didn't come out all nice and even, did it?
Yeah.
And guess why we don't use seven-sided figures? Because it doesn't come out all nice and even. We use the stuff that works out a little better. Eight-sided, do we ever use them?
yeah,
Yeah. Nine-sided? Not a whole lot, but maybe. 10-sided? Yeah. 12-sided? Probably not, but I threw it on there just to have that extra one.
It's so easy.
Next one, this column. How would you find that column? First, let's do this down here. What's going to go in the very bottom down here?
and would that be n minus 2 times 180 over n?
Over what?
N
Over n, over the number of sides, right?
So it's the sum of.
That's the formula. Now, is that the easiest way to find each of these? Once we know this column, I'm hoping all of you filled in this last column, right? Once we know this column, what do you know about an exterior angle and an interior angle?
Add up to 180.
They have to add up to 180.
Okay.
So what's the easiest way to find each one in this one?
Subtract them by 180.
180 minus whatever number you stuck in here.
What do you want us to do?
So what's the first one going to be?
16.
What's the second one going to be? So on, so on. Fill in that column.
Why did 12 and 8 come out the same number? They both came out 135.
What?
No, that one's wrong, actually. This one should be. No, it is 30.
You take the sum of the interior
30, this should be 150. This should be 150.
number of sides.
It should be 150 for that.
I'm just happy with it because you're actually doing what you should be doing instead of. That's all right.
Mr. Ebersole.
Well, you take the sum of the interior angles.
Everybody got both those columns?
Yeah.
No.
It's 150.
Getting close?
Almost, yeah.
What do you want us to put down for 7?
We'll talk about it here in a second. Looking at this column, the exterior angles, each exterior angle. Anybody, first let's look at this column. What happened? You guys figured out the pattern. What was it?
That added 180.
Added 180. So it was getting higher every time, right? So every time that you add another side, the shape's getting bigger. What's the limit for this column then? How high could it go?
Go ahead.
It could keep going forever and ever and ever. Right? If you have a million-sided figure, it's going to be a really, really big number. All right? What's true about this one?
That one down there.
Sum of the exterior angles. Does it get bigger every time? No. What's true about it? It stays the same for every shape, no matter how many sides the shape has. What's true about this column? What did you notice about this column as you went down through here?
Kept on getting smaller.
So each exterior angle got smaller. What was true about this column?
It got bigger.
Each interior angle got bigger as you go. So if we had a million-sided figure, what's going to be true about the each interior angle?
It's gonna be huge.
It's going to be some big thing. Now, don't say it's going to be huge, because it's never going to get to how much?
180.
It's never going to go past 180. So it might be like 179.9 or something like that. But it's never going to get bigger than 180. Same thing with the exterior angles. All right? They're never going to get smaller than what? 0. They can't go down to 0. Otherwise, you wouldn't have an angle.
How many sides do you think that circle has?
2. An inside and an outside.
Well, I'm saying because there's a lot of pixels. That's pretty good. A lot of sides. Circle doesn't have.
Now, on the 7-sided figure, this is what I want you to write down.
Inside and outside. That was terrible.
I thought it was pretty funny.
7-sided figure, and on the rest of it, check to make sure that all your answers are written in correctly.
Incorrectly.
Written in breath correctly. So you have them all
Correct.
written in the diagram correctly. See, I'd almost be upset, but that means that Ethan O is actually paying attention for once this year.
For once. Might is at least twice.
Might be twice.
It's at least twice. I'm hungry.
So
It's getting
you're
hard.
A lot. Yeah.
Make sure that they're all right. Notice with you guys, for the 7-sided figure, again, goes back to being a teenager. Everybody wanted to say, how do I round it off? How did I round mine off?
That's fractions.
I didn't round it off. I wrote it as a fraction. That's what you should do. Don't round crap off. Start learning what the fraction numbers are for some of these things so that you can write it as an exact answer and not a rounded off answer. A better form. Again, for a 7-sided, and here it says septagon, it could also say what? Heptagon. So make sure you don't forget that name. They could throw either one of them at you. But what did we say about a 7-sided figure again? Don't use it very much.
You keep on going. Is it just additions of 7 that's gonna do that?
No.
No.
Well,
Do you know what I mean?
It will do something like this.
Yeah.
Because you're dividing by a multiple of 7.
Okay.
But those aren't the only ones that are going to come out not evenly. Everybody have all those right?
Yeah.
On the worksheets that you picked up, on the worksheets, grab them. We're going to work all these together. The quicker we get them done, the quicker you get to move on to your assignment. So everybody find this first one. Any trouble finding it? How about your calculator so you can help us? First one says, find the sum of the measures of the interior angles of a heptagon. 900. Where could you find that at?
On a chart.
It's right there on your chart. It's going to be hard for me to write because it's not going to like writing on this. Can everybody tell that that's supposed to be 900?
Man, that looks huge.
It's a picture, so it doesn't like writing on pictures.
Really?
Yeah, you see all the
Use your marker.
Yeah, but then the people who is making the video can't see it.
It's like,
Yeah. The next one. The sum of the interior angles of a convex polygon is 3,060 degrees. Classify the polygon, in other words, name the polygon according to the number of sides. The sum of the interior angles. Well, the formula for sum of the interior angles was 180 times n minus 2. That's supposed to be an n there. We know that this time that should equal how much? 3,060
degrees.
All right? If we're setting this up, I highly suggest that you write that down on your paper there. If you, I know it's hard to read, but it's 180 parentheses n minus 2 close parentheses equals 3,060. So we're working this formula, but we're working it backwards. It's not very difficult. It looks difficult, but it's not as hard as it looks. If you're doing this, the first thing I would do, divide both sides by 180. So grab your calculators. What's 3,060 divided by 180? 17 our answer?
No.
What's left on the other side if you get rid of those 180s? N minus 2. How do you solve for n there? Add 2 to both sides, right? So add 2 to both sides, what do you get? N equals 19. So how many sides does this shape have?
19.
So what do we call it? A 19 gon. 19 gon. Find the measure of each interior and each exterior angle of a regular 30 gon. Again, if I'm doing this, do I want to use that big long formula? I want to use the one for exterior angles, which is 360 divided by n. How many sides does this shape have?
30.
30. So grab your calculator. What's 360 divided by 30?
12.
So how much is each exterior angle? 12 degrees. What's the easiest way to find each interior angle once we know the exterior angle? 180 minus 12. That's 180 minus 12. What is 180 minus 12? 168. 168 degrees. So each interior angle is 168 degrees. Each exterior angle is, that's supposed to be a 12. It's 12 degrees. Next one, number 4. And I'm going to sort of quit writing on this, so you just have to, maybe I will just use the pen. On number 4, how many sides does that shape have?
5.
5?
Oh.
So what do we know about all the interior angles if it's a 5-sided shape?
540.
Does everybody find that on their chart? They add up to 540. Now, is that the answer we want?
Yeah.
No, we want
X?
what x is. How are we going to find that?
The bottom angle is 90 degrees.
So grab your calculator, and what do you do with all these ones that you know? Add them all up. So do that. Add all those up.
456.
Anybody else get that?
Yes.
That angle is 84 degrees.
So 456, how do we find that remaining angle?
540 minus 456 and it's
456 minus 540.
And you get what?
No.
84 degrees. So x equals 84 degrees. Next one, count for me.
1, 2, 3, 4, 5, 6.
6. It's got 6 sides. Is that what we're going with?
Yeah, 720 degrees.
So they should add up to 720. Add up all the angles. What do they all add up to?
595.
Anybody else get 595?
Crap.
Yeah.
Yeah.
Subtract that. What do we get?
I got 451.
All right, then maybe we better add it again.
I got.
You missed the sign, you missed the sign.
Oh, I forgot the. No, I didn't.
Is it 595? Is that
Yeah,
what we're going with?
that's what I got.
It's 595.
All right. Subtracting, what do we come up with?
130, 125.
125. So what's x equal?
125.
125.
Yeah, I did this time.
So it makes sense for x to be 125.
Yeah.
Now, if Riley had went ahead with his number,
Oh, about it wrong.
but could he tell that it was wrong?
Yeah.
Because the angle's going to come up to more than 180. And you should know, hey, it shouldn't be that. Next one. How can we find these two angles?
So you have
You
90
add
and
the-
120. So you add
It's
those together.
210, and then you subtract 360 minus 210.
So 360 minus 210, what's that give us?
150.
150, and then you divide that by 2.
Divided by 2, so what's x?
75.
75 degrees, what's y?
75 degrees.
So 75 degrees. How many sides in the next shape?
6.
6 again, so what all those add up to?
720.
720. Somebody add up the ones that we know.
360.
360, anybody agree with that?
I got 450.
450?
What am I doing?
I also see.
You're not clicking the calculator.
I got 450.
I got
450?
I got 360.
360?
Thank you.
Oh wait, plus 9. I forgot.
I got, yeah, it's 450.
Thank you.
450?
Yeah, 450.
Subtract them, what do you come up with?
270.
270. So does that mean our answer is 270?
Divide that by 2.
Divide that by 2.
135.
What's x?
135.
135, 135 degrees. What's the angle y here?
135.
135 degrees.
This one's not hard.
Exterior.
Next one. A pentagon.
Okay, we're skipping 8 now.
I don't know, did I skip one?
Yeah.
Skip 8 and 9.
Did I? Tell me what they are and we'll do them.
It's just
150.
Oh, it's the exterior angles. I just forgot to put them on here.
Divided by 2.
So the exterior angles, look at number 8. What do we know about the exterior angles of that shape?
Yeah, it's 360.
They should add up to 360. So take 360. Somebody add up all the angles that they tell us on that one.
48.
Get two.
It's 152.
152, anybody else agree with that?
I got 208.
208?
Yeah, that's what I got. Never mind.
208.
208?
360 minus 208 is 152.
and then you divide that by 2.
That's 152.
76.
So there's 2 x's, so each x is how much?
76.
76 degrees. Everybody agree with that? That's answer number 8. Number 9, what's all those exterior angles add up to equal?
272.
What should all of them add up to equal? Let me say that. All of them. 360.
Oh, yeah.
So 360 minus 272, everybody agree with that?
Yeah, 88.
88, is that our answer?
Yes.
There's only one x,
Yes.
Yeah.
so 88 degrees is x on that one. Number 10, a pentagon has 3 angles that are congruent and 2 other angles that are supplementary. What's supplementary tell us?
And
Add up to 180. So for this pentagon, how many sides does a pentagon have? 2, 3, 4, 5, So they're saying that these three angles, it doesn't matter, I'm just marking them. Those three angles are congruent, and what do we know about these two angles?
Yeah.
They add up to 180. So something like that, it doesn't matter as long as it's got 5 sides. What do we know about all these interior angles on a pentagon?
They add up to 540.
540, everybody agree with that?
Yeah.
What can we do first?
Minus 180.
Minus 180. We know that those two add up to 180. What's 540 minus 180? Grab your calculator. 360?
I just,
Is that our answer?
Divide that by
The other three are the same, so we're going to take that answer and divide it by
120.
3. So each of those angles is
120.
120 degrees. Next one. You are designing an amusement park ride with cars that will spin in a circle around a center axis. And the cars are located at the vertices of a regular polygon. How many sides does a regular polygon have?
Don't know yet.
We don't know, do we? Alright, it's just some polygon, we don't know how many sides it has. The sum of the measures of the angles is 6,120. If each car holds 4 people, what's the maximum number of people that can ride the ride at one time? So when I'm drawing this, I have no idea how many sides the shape has. I'm just going to draw something like that. Alright, like it's cut, like it's broke here. I don't know how many it has. Alright? We know that it's regular, so what has to be true about all these angles? They have to be congruent. They all have to be the same. They told us that all of them add up to how much? 6,120.
Oh my goodness gracious.
What's the formula for all the sum of all the interior angles?
N minus 2 times 180 equals 6120.
That's the formula you might want to write down there. The equation you might want to write down so you know how to do these.
Okay, so
Now to solve that,
36.
easiest way, if we're multiplying this by 180, what's the opposite of that?
divided.
So divide both sides by 180. Over here, the 180s cancel out, and you're left with just n minus 2. Somebody help me out on the other side.
34.
34, everybody else get that?
Yeah.
My calculator.
Are we done?
No.
You gotta add 2.
Add 2 to both sides. What's that tell us?
That the number of sides is 36.
So it's got 36 sides. Are we done?
No.
What'd they ask us for? Go back and read the problem.
How many
What's the
people?
maximum number of people who can be on the ride at one time?
So how can we figure that out?
Okay, well each car holds 4 people, so we gotta figure out the number of cars.
So you got a car here at this corner, right? Car at this corner, car at the next corner, so on and so on.
There's
So it's gonna
36
be
of them.
36 times 4.
There's 36 cars.
Each one can hold 4.
Each one can hold 4, so what do we do? 36 times 4, what's that give you? So how many people can ride the ride? 144 people.
Dang, that's a lot of people. Why is there so many people? That seems unnecessary to have 144 people. I want to be just cool.
Next ones, let's run through these real quick. These should be easy, right?
Sure.
Number 2 is kind of complicated.
Number 1, somebody go through. How many sides?
1, 2, 4.
4 sides, so all the angles should add up to how much? 360. Somebody figure out what's x.
Okay.
103.
103, anybody else get that?
Yeah.
So 103 degrees. What could you do to check to make sure?
Plug it in.
Stick it back in there, and what should all those add up to? 360. Next one, how many sides? 5 sides. What should all those add up to? 540. So this time, we're gonna do 540 minus, what'd you get when you added all these three up? 336? Let's subtract that, what's that give you? 204, is that our answer?
No.
This time we're dividing it by how many?
3.
Divide it by 3, because there's 3 x's. What's that give you? 68, so x equals
68.
68.
Okay.
So if you were to get the measure.
Now, if we wanted to measure of each angle, what's this angle?
68.
68, how would we find this angle?
136.
136, double it, times it by 2. Next one, somebody tell me the measure of angle x and the measure of angle y. How many sides does that shape have? 5. So what should all those angles total up to be?
540.
540. Subtract off the ones we know, 88, 130, and 90. And then divide that answer by 2.
116.
This angle's 116. Everybody agree with that? Yes, no, maybe? What's angle y? 116. How many sides in number 4? 6. So all those should add up to 720. Subtracts what from 720? 200. What's that leave you with?
520.
520. Divide that by 4.
130.
130. Everybody agree with that?
Yeah.
So that angle's 130. That one's 130. That one's 130. That one's 130. Next two. Does it matter how many sides these next two have? No, because we're dealing with which angles? What do you know about the exterior angles? They always add up to 360. So 360, and you subtract off the 3 that you know here. And you take that answer and you divide it by 2. What's x end up being? 56. Anybody else get 56? Yes, no, maybe? Yeah? Ooh, next one a little harder.
It's 55 degrees.
What do we know about all of this? Should all add up to how much?
360.
Should all add up 360. How many x's do we have? 6 x's, so 6x
Plus 30.
plus 30 should equal
360.
360. Write down that equation for number 6, and then you're going to solve it.
Is it 55?
55.
That's what I got.
Anybody else get 55?
I got
55.
62.
That's what x is. Next ones. Find the measure of each interior angle and each exterior angle of a regular 24-gon. Which one's going to be easier to find? Each interior or each exterior?
Exterior.
Exterior. For the exterior, you just do what? 360 divided by 24. Do that on your calculator real quick. 15. So each exterior angle is 15 degrees. How are you going to find each interior angle?
180 minus 15.
180 minus 15. What's that give you?
165.
165. Everybody agree with that? Those are your two answers for that. Number 8. Each exterior angle of a regular polygon has a measure of 18 degrees. Find the number of sides of the regular polygon. What's the formula to find each exterior angle?
I just zoned out really.
360 divided by n, right? Well, we know that 360 divided by n this time is what? 18. Anybody know how you're going to solve that?
You gotta multiply by 360. No, multiply by n, and then divide by 18.
Alright, so when you're doing this, several different ways to do it. It's totally up to you how you do it. A lot of times I'll tell students to put a 1 underneath that and cross multiply, but then that seems to confuse people. Kellen's sort of right. If you're dividing by n, what do you got to do?
Multiply.
Multiply both sides by n to get rid of that fraction over there. What's left on the left-hand side?
360 equals 18.
You can just divide by 8.
Now what do you do? Divide by 18.
20.
So n equals what? 20. So it said find the number of sides. How many sides does this shape have then?
20.
20.
And then,
Number 9. A polygon has 2 pairs of complementary interior angles. What's complementary mean? They add up to 90. How many sides does this shape have?
2 pairs of, so 7.
14.
Oh, no.
So it's got 2 pairs of complementary.
10.
So we got how many angles so far if they're complementary?
2.
2, then another pair. So far how many angles are we at? 4 angles. Then it says 3 sets of supplementary angles.
Wait, so it's.
So what's
17. No.
supplementary mean?
Add up 20.
So 2 angles that add up to 180. How many of those do we have?
20. It's just 20 sided.
It's not 27.
How many of those do we have?
3 sets.
3 sets. So these add up to 180. These add up to 90. The sum of the remaining angles is 400 or 1,440.
That's 10 sided.
How are we going to do that?
So.
What do we know about these 2 here?
They add up. There's 10
They add up to 90. How much do these 2 add up to?
What's the other?
How much do these add up to?
I'm not sure.
4.
90.
90. This pair, how much do they add up to?
180.
180. This pair,
180.
180. This pair,
180.
what can we do with all those to find the total sum of all of them?
Add them all up.
So do that.
Easy way to do that.
2,160.
2,100 and what?
60.
So we know all the interior angles add up to how much?
2,100.
2,160. Was that one on your chart?
Yeah.
No.
It is?
No.
No.
It's not on there?
Just better though.
So we know it's more than 12 probably, right? So if we don't know that, let's see, what's it asking us again? How many sides? So it's just asking us to find the number of sides. So we do the same thing that we just did on the other one. We take n minus 2, and I pointed over there, but it's not over there anymore. N minus 2 times 180 should equal a total of how much?
1,160.
So write that equation down. What 2 steps are we going to do to solve that equation? First you do what?
Divide.
Divide by
180.
180. These 180s cancel out. What's left on the left-hand side?
N minus 2.
N minus 2. What's left on the right-hand side?
2,100. Oh, wait. 14.
14. Anybody else get that?
12.
12.
12.
Then add 10.
Now what?
Yeah.
Subtract 2.
Yeah, that's
Subtract 2.
Add 2.
Add 2 to both sides. So what's n equal?
14.
So how many sides does this shape have?
14.
Next one, this part's cut off of yours, and we're not gonna do it because it's cut off yours, but the top part is there. It says find the sum of the measures of the interior angles of the polygon. How many sides does this polygon have?
6.
6. So how could you find the sum of all these angles?
I don't know.
How could you find the sum of all of them? We don't have to do all that.
Is it?
You just told me, you just looked where?
Got my sheet.
Your sheet. What's the sum of the interior angles if
720.
it's got 6 sides? 720 degrees.
Well, we don't know one of the sides is 8.
So, yeah, that's why I said we're not finding the second part. What's that first part asking?
Oh, easy.
Says find the sum of the interior angles. Well, if it's got 6 sides, the sum has to be 7 points.
Oh.
But it equals 5.
Rocky, man. He likes to pick me up, baby.
Oh, yeah.
I don't think we're out.
Can we get back our old books?
No,
Can I burn it?
no, because we're gonna need it.
Burn it. What in the world?
I know, I keep my book back.
You know what? You might make it back.
Oh, you got another little
Make sure, grab a book, make sure you grab a book. Don't come in here next time and say, oh, I didn't grab a book so I couldn't do the homework. I won't care. Grab a book, make sure it says volume 2 on the front.
It does.
Make sure it says volume 2 in case they got mixed up with something.
Oh, okay. It's not that bad. I like the dude on the back.
Right, yeah.
You see my vocabulary.
We'll be done with volume 1 here pretty soon. I skipped the chapter and we're going like out of line.
Well, why are we going out of order?
Well, there's a way now.
Oh, you get me one.
You got your, I didn't hear you, alright?
Yeah, all right.
Mr. Bugs calls me Rodeo.
Hey, did I tell you what
He's not wrong, but you didn't see what I said.
Hey, Romeo.
I think he's lying, but I think he wants to. He's trying to take it out. Yeah, it makes people very angry if you take that flower. Incarcerate your mother.
Huh?
Yeah, I know.
You ever heard of a urine action? You need to learn that. Not your Valentine's.
Hey,